Okay. Can everyone hear me? Can anyone hear me? Okay, I see a few thumbs up. Excellent. Great. So we still have people joining at a rapid rate. We'll probably wait a minute or two, but just wanted to welcome everybody. This is our kickoff meeting for the InSAR, ICE, MintPy, ARIA tools, Openstar Lab training. And it's recorded, so some people who will not be able to make it can view it later. And we're also going to repeat this on Monday if you still have questions. But we have an agenda today that will go through introducing our instructors, introducing some TAs who have volunteered to join with us from the student group who have some experience with InSAR, going over the structure of the course, reviewing the syllabus, and talking about the pre-course and the actual course itself, and then looking at the resources that we have available to you, and then talking about the assessment component of the class, and then some training, quick training on the cloud-based tool that we're going to use for the work. So that's what we're going to cover in this hour. Hopefully I won't talk too much, as I often do, to fill up too much time. So let's see where we are with the count. We're at 75 participants on this Zoom meeting so far. We have, I think, 150 students who are registered for the class. So maybe half will show up on Monday. We do have in the chat a link to the syllabus, thanks to Becca. So, and you can also see in the chat a pre-survey set of questions, but we'll go over that in a bit. So let's see. I think the first thing we want to do is to introduce the instructors. So I am Paul Rosen. I'm at NASA JPL. I have been doing InSAR for a long time, and I'm sort of the coordinator for this class, but a lot of the work and the training is going to mostly be done by others in the instruction pool here, instructor pool. So we've been working on this class in various forms for the last 5-6 years. Actually, maybe even longer, but from a cloud-based perspective, the last 4 or 5 years. And we feel it's getting more and more convenient for students to be able to work with InSAR data, with the Sentinel-1 data that's now available at the Alaska Satellite Facility and other locations. There's a huge amount of data to look at. So we feel we're getting to the point where these tools and data sets are really becoming super exciting and useful. So we hope that you're going to enjoy this class. Let's see, the best way to go on to the various instructors is I'll just call out your name and just say who you are, where you're from, and pretty much what you like to do in this field. So Gareth Funning first.
Hi, I'm Gareth Funning. I'm faculty at the University of California, Riverside. What I like to do, I like to process interferograms of places undergoing tectonic deformation. For me, that's mostly California, but I also have a sideline in looking at earthquakes the world over. I also had dabbled a little bit in geothermal areas and modeling those. And I've been processing interferograms since the year 2000. But only recently have I moved into trying to teach the world how to do this. And I think it's great fun. So I'm looking forward to this. I'll see you around.
Thanks, Gareth. Next up is on my list is Frans Meyer.
Hey, good to see you all. Frans Meyer from the University of Alaska Fairbanks. I'm here faculty at UAF teaching microwave remote sensing. And I also am the chief scientist of the Alaska Satellite Facility. And I guess what I like to do in both these roles is scientifically, we work on processing methods, data correction methods. We've been working a lot on things like atmospheric and ionospheric correction of SAR data and InSAR data. And otherwise, we work heavily on hazards, natural hazards. We have made sure that people have access to higher level data for volcanoes and earthquake events. And we're also working heavily on things like mapping of and analyzing of flooding events. We've also worked very heavily on education and training in SAR and on creating tools that make it easier to do capacity building in the field of SAR. So the Openstar Lab that you will be using this week, if you have issues with the Openstar Lab, the person to blame is me. Hopefully it's going to work fine. We have a small team that will support us from ASF to make sure that everything goes over smoothly.
Yeah, thanks, Frans. Yeah, Openstar Lab is sort of the brainchild of Frans, and it's really quite effective. Let's see. Not all of our instructors are on today. We told them yesterday at our pre-planning meeting that if they were busy, they wouldn't have to be here. So I'm just going to read out some names who I don't believe are here. Haresh Fatahi, he has been developing tools for InSAR. He is now actually the lead for algorithm development for the NISAR program at JPL, as well as a new program for doing value-added processing on Sentinel, NISAR, and other data sets. JPL, it's called Opera. So he will be joining us during the week. Brent Minchu is a professor of geophysics, and I think he specializes these days in glaciology at MIT. I don't think Brent is on, just checking quickly. Yeah, so he's going to be teaching 2 new modules in estimating glacier velocity and some of the physics behind ice motion. That should be pretty exciting. The next on my list, I believe is on, yeah, I see Yunjin there. So Yunjin, can you introduce yourself?
Hi, I'm Yunjin Zhao. I'm a postdoc of geophysics at Caltech. I like to do developing algorithms to make InSAR more accurate, and I also like to develop tools for InSAR to make it more easier to use. And I also do a lot of time series analysis for InSAR, and I usually apply InSAR with geophysics tools to study volcanoes and earthquakes. I think in my generation, I started playing with InSAR time series already directly with skip-to the interference when I first started to learn InSAR, and that's been like around 10 years ago.
Great, thank you. Next on my list here is David Beckert. I don't see him on the list of participants either. He's at JPL. He's also very busy. He's a project scientist for this program called Opera that I mentioned earlier, which is creating global value-added products from Sentinel and NISAR and other optical data sets as well. His expertise is in InSAR and atmospheric corrections and models and things like that. Another instructor who I don't think you'll see at all, but who has helped us develop these materials is Scott Hensley. He's an InSAR expert and polarimetry expert here at JPL, has been working many years side by side with me and helped develop a lot of the techniques and programs that we've written over the years. So you won't see him, but you'll certainly feel his influence. I think that's it for the instructors who are directly participating. In addition to the there's also our assessment person. I'll introduce Hillary Davis.
Hi, everyone. My work is in cognitive science, understanding how people learn and what experiences enhance that learning and how people use it. So I'm the external evaluator for the funder that looks at what you do and how you do it and what effect it has on you. So I will be asking you to do the pre-survey before you start, and I put the link in. I'll put it again for those of you who joined later. You should complete that before you start the course next week. And then as soon as you finish the course, you should take the post-survey. And those are requirements, especially requirements of your participation, but also especially if you think you might like a certificate or course credit. But we would just really appreciate it if you would do that. And as you know, a pre-test or pre-survey is really just for you to have a sneak preview of all the core ideas that you will be investigating and learning in the course. So there's no stress attached to that. This is confidential. I ask for your name, but only to track your participation. If you don't do the pre-survey, I will remind you because we really want to hear from everyone so that we have really good data. So it's nice to meet you all, and I look forward to lurking in the course and seeing all your hearing all your great questions.
Yeah, thank you, Hillary. And as I think we may have announced, we're expecting good participation from everybody, both in the technical content and in the assessments, because it's important to our funder for the work that we're doing that they understand how effective our training is. So we had 400 and some odd applicants for this course, and we selected 150. You may recall a month or two ago, we sent out an email letting you know how that there is work involved in this class, and if you're not up to it or you don't have the time, that we appreciate you relinquishing your spot for others. And we had a few people drop out. The other 150 stayed in, or the other 100 and some odd, for a total of 150 are now participants. So we're looking forward to your active participation for the entire period. So next on the intros are some very important people. We have, for the first time actually, an intern at UNAVCO who has been able to help us get organized in a way that we've never quite had before. Her name is Becca. So maybe you want to introduce yourself?
Yeah, I'm Becca. So I've just been helping with logistical stuff of the course, and I will be around too if you have any questions. I am a third-year PhD candidate at University of Oregon, and I used InSAR over a bunch of different volcanic systems. And I've used ICE and MinPy for a fair amount of time, and I have processed some interferograms, and I've also got a lot of errors with them. So if you run into any issues, I will probably know what they are and be able to help.
Great. Thanks, Becca. And then we also have 4 students who, from the class, who volunteered to be TAs. They have had some experience already, perhaps not with these specific tools, but with InSAR in general. And they are going to be helping with collecting, cajoling, and grading homework and things like that along the way. And hopefully they'll also be able to help answer questions along the way as well. So those 4 people are, I'll just start with Luyan Bai. Do you want to introduce yourself, Luyan, if you're there?
Yeah. Thank you. Hi, everyone. My name is Luyan, and it is now I'm doing my postdoc in the National Center for Airborne Laser Mapping, STANCAM, at the University of Houston. I'm now working in LiDAR more precisely. Recently, I am working in LiDAR, but my main field before is InSAR, because I did my PhD in InSAR. And this is the first time I have joined this class. And as Paul mentioned, I will be serving as a TA. I have used ICE, Giants, and stamps before. And from this course, I just want to update my knowledge and experience in application of ICE and MinPy. And my main application is the application of InSAR in land deformation regarding water, groundwater. And I'm really interested in the application of InSAR associated with sea level change. Yeah, thank you so much, and nice to join the class.
Great, thank you. Okay, the next 3 on the list are in Asia, so it's quite late for them. I'm not sure they're all on right now, but I do see Shubham, so maybe you can introduce yourself.
I'm Shubham. I'm working in Indian Institute of Technology, Roorkee, IT Roorkee, and I'm basically working as for InSAR for groundwater monitoring and deformation monitoring. So actually we are working with the urban areas, and most of the how the groundwater is basically leading to the deformation in those areas. And as per tools, I'm working with the ICE also, and most of the time ICE and stamps I'm working with.
Very good. Thank you.
Most welcome,
The next is Faizan Sabir. Are you there, Faizan? He's in Pakistan. Maybe is asleep on a Friday night. Okay, and how about Pratyusha Konuru? Are you there? Okay, so they'll perhaps come on the Monday training introduction. All right, I think that's it for introductions. Did I forget anybody? Fellow instructors? Melissa's not on, right? So Melissa is our UNAVCO coordinator who's been doing a lot of work behind the scenes.
And Becca, I would just add that Becca created a teaching assistant groups with homework tracking, and I put the link in the chat. It's also in the syllabus, I think, but this is where you'll indicate you completed it, and then your TA will be able to grade it. And it's pass fail. It's just a tracking tool that you might want to bookmark.
Yeah, we were going to go over that later, but that's okay. Thanks for bringing that up because I might have forgotten. Oh, it looks like Faizan is here. Great. He's trying to connect, but has poor internet. So great. Great that you could make it on the chat. All right, so let's go over the syllabus. That's the introductions. Let's see if I can share this. Everybody has the ability to see this. It's in the link. So Becca, do we have a place on the Slack channel where we just have a place people can go and click on all the relevant links, like the homework link, the syllabus link, the
No, but I can make a message and then pin it in the general chat. That way it'll stay at the top of the screen so people can always access it.
That's the only way I'll be able to remember where they are.
Yeah, I can make that after this call.
That would be great. Okay, let me see if I can share my screen, if I have the ability to do so. Hopefully you can see the syllabus now. Maybe not big enough. Let me see if I can make it any bigger. There we go. That should be hopefully big enough for you. All right, so Hillary has cleverly put the links to the surveys up at the top so that you see it right when you come in and look at the syllabus. So I think you all know why you're here, so we don't have to go over the summary, but as an overview, we have this segment of pre-course activities starting next week, which is primarily self-directed, where you're going to just refresh your memory on a number of things related to the interfaces that we're dealing with, and some of the modules that we could not fit in the actual full course. We moved into the pre-course period thinking that they were well enough self-directed and straightforward enough that you'd be able to work with them separately. The one thing that perhaps does not fit in that category, but that we moved into the pre-course anyway, is the SAR background, synthetic aperture radar background. This, we used to have a 1 hour-ish module during the actual class, but because we're fully virtual and we decided to make the instruction about half the usual time, we had to put some things into the initial period. So the GIS using GDAL, software installation, SAR theory, that kind of stuff, we used to teach directly, and now it's in the pre-course material. The good thing is that almost all, I guess all of these things that we used to teach have videos associated with them from previous years. And you can follow those videos next week. And it's maybe almost as good as being in the class. We also will have office hours next week. at several times, I think 3 times, where if you have questions on these pre-course content lectures or notebooks, you'll be able to ask us. So that's all good, I think, and you'll let us know one way or the other if you agree. Then for the actual course, we have a 5-day set of exercises, mostly run through Jupyter Notebooks, but some lectures with PowerPoint presentations to cover all the things that you see here. Yeah, everybody should mute yourselves if you can. Or Becca, you can mute them. Thanks. Start out with some, overview of geophysical modeling, InSAR theory, and then we jump right into strip map processing using the ICE processing workflows, talking about all the various aspects of setting up the data, all the different steps of the processing. And I think ionospheric corrections is actually a later day. Day 2 is interpreting interferograms, once you've created them, and then a good chunk of time spent on using the TOPS processor, which is the processing methodology used for Sentinel-1 data. It's a different kind of imaging system than most conventional strip map SAR processing, so we have a separate workflow for that. And then we have on the 3rd day, so these new modules I mentioned on glacier interferogram formation, understanding those interferograms and understanding the processes at some level associated with those. And then we jump into preparing data for modeling, and we talk about tropospheric and ionospheric errors in data sets, which are pretty much the dominant error sources that you'll be dealing with on a regular basis. And then on day 4, we talk about time series, stack processing, and offset stacks associated with what you might use for fast-moving ice flows and things like that. And then day 5 is focused on MintPy and the ARIA tools methods. ARIA tools using data sets that exist in the so-called ARIA system, where you have pre-processed interferograms that are unwrapped that you can download and use directly in the time series analysis. So that's sort of an overview of what we are going to be doing for the next week and the following week. Again, next week is the pre-course period, which is primarily self-directed with a few office hours. Following week is the instruction. So here is a little more detail on the pre-course content. Some of these have videos associated with them, and I believe in this we have links in this syllabus document. We have links to the places where there are videos available to you. For the math, we have a notebook, Math Basics notebook that's in the system, the Openstar Lab system that you're all going to be introduced to later. And some of you have already, I think, used it and found at least one bug in them. These will just give you a background on what you should know in order to be able to succeed at this class. It's pretty straightforward stuff for geophysicists and engineers. If you're not in one of those science areas, you should let us know so that we can go over this with you. But it is kind of helpful to have this background. We don't actually have much in the way of training materials for Python, Unix, plotting, and NumPy. My personal belief is that the notebooks we train with are self-contained enough that probably you can pick it up as you're going along. But I'm hoping that you will go to some of the resources you can find on the web. I don't know why this is a slash and a dot here. That must have been deleted by accident. I think we had another link there. We'll go back and fix that. But these are things that you should be familiar with enough so that you have, you know what the notebooks are saying to you, and you can modify them. We are going to have training on Openstar Lab in this lecture. In this hour, we're going to have some quick introduction to it so that you can get started. Next week, Frans is going to give an hour-long tutorial. And if you want to get started early, you can look at last year's video that is at the link in this syllabus. There will be differences between the last year's environment and this year's environment. So it's probably a good idea if you are unfamiliar with the cloud interface that you attend the lecture next week as well, if you can. For the GDAL video that's there, I think we discovered perhaps that some of the data resources are missing. So we need to find those data resources and put them on the page. But the video will walk you through how to use GDAL for what we're doing in this class. So Frans, is there yet ASF step-by-step instructions on installation that you were going to put?
No, by the end of the training, you all get access to a Docker container, and there will be instructions that come with it. So once we spin down the deployment for this particular course, we'll provide you the information you need if you wanted to run the setup you had on the Openstar Lab on your local machine.
Okay, so this is
not in here, but it will be provided as we approach the end of the course.
So I should change this. Okay, so this is not a pre-course activity then. We should probably move that out of the pre-course section here. Then there's the data search and access video that you can have access to, and then there's a module on raster data tiling and map projections that you can also look at. So then here's the SAR part. There's two aspects of SAR. One is the sort of phenomenology, which is a lecture that I would give in class previously, and this video is the lecture from a previous year. That hasn't changed much. I think this one might have more material in it than in the notebook that exists in our environment this year. But it's good to go through that video. It has all the relevant material. You'll learn about, backscatter and speckle phenomena and signal to noise ratio and all the various aspects of SAR that hopefully will be useful for interpreting the imagery you'll see during the class, as well as the characteristics of images that lead to interesting aspects of InSAR. So I really strongly encourage you to go through this video, because we just jump into a lot of the material using the language and nomenclature and concepts in this module in the class. So please do go over it, hopefully earlier in the week, so that with the office hours, we're able to address any questions you might have. And then totally optional, but for those of you who have some background and are really interested in overall SAR image formation process, I put together a notebook called SAR Imaging Theory, which is fully self-directed. You don't have to take it if you don't want, but it leads you step by step through everything you need to know about forming an image. It even has a simulator, a little point target simulator at the front end of it that allows you to process the data from raw data into a full image using 2 or 3 different techniques. So if you're interested in that, it's really worth spending some time on it, but you don't need to do it. It's not required for this class. Okay, and then the instruction itself, that was all self-directed. with the office hours that we'll talk about in a minute. For the class itself, starting on August 23rd, we've got Zoom links. They're all posted in here, so you should be able to find them. And we start at 10 o'clock in Pacific time, which is, more or less convenient or inconvenient, depending on where you are in the world. We apologize for those who will be up half the night for this, but it turns out there's really not a good time to get everybody in the world for a Zoom related training. But so you can see the details of all the activities that we're going to be going on that I already went over, so I won't go over it again. There are links here also for the previous year's instruction of these things. If you really are eager, you can look through these things next year. Most of the content has not changed in a dramatic way from previous years. So if you look at these videos, it should look familiar when you actually take the class. So this is Monday, we do the strip map processing. On Tuesday, we move into interpreting interferogram and the TOPS processing that I mentioned before. On Wednesday, we have a module on glacier velocity mapping and interpreting interferograms from glaciers, preparing data, and tropo and ionospheric errors and mitigation methods for that. Then on Thursday, we have time series methods, stacks with the ARIA tools, which allow you to pull from an archive of already processed data, and then a module on offset stacks that Brent Minshew will be giving. And then on Friday, we have the introduction to MintPy that Yunjin will be giving, as well as time series analysis with MintPy. So that's an overview of the class. Each day is roughly 10 to 2 or thereabouts Pacific time. And of course, there is a pre-course survey link to take before you start the training, so that we know what it is that you do know in advance. And then the post-course survey is extremely important because we get to figure out whether you actually learned anything. And that's important because we've actually used that material from last year to try to make improvements for this year. So we'll see if that had the desired effect if you take these surveys. All right, so at this point, are there any general questions on the syllabus? We will be sending out links, Zoom links, as calendar attachments, the .ics files for office hours and for the class themselves. If you haven't received them, I think you might have already received the class calendar invites. So that should all be straightforward and clear. We can also list maybe in the Slack the times and Zoom links for these things if people feel that's necessary. So there may be some questions about the exact timing of the various things. That will become apparent as we get into it. Any other questions? You can either chat or raise your hand or something like that. Clear? Sounds like it's very clear, or you didn't understand anything. So hopefully it's very clear. So with that, I think, I don't know, Hillary, do you want to say a few more words about the assessment?
Yes, at the beginning in the syllabus, you'll see that there are the objectives, and that the team worked very hard on that for you so that you can focus your work, your activities on that. There's information about what they think you should learn. So it's on you to make sure that they deliver. So this is your chance to be sure to ask questions if it's not clear, to really clarify what you think you've learned in the notebooks. And that will get the best results for you long term. So we're very excited that so many of you committed to really working this, because this is the kind of course where the instructors have spent an enormous amount of time really thinking about how best to use your time and how best to take advantage of their expertise. And so please take advantage of that by making sure that you're actually learning what they think you should be learning in each section. That's it. Thanks.
Great. Thank you, Hillary. All right. I see a lot of questions about links and where to find information and that kind of stuff. So as far as resources are concerned, we have the Slack channel. I think we have over 116 people signed up on the Slack channel. And the syllabus itself will be posted there. And the link has already been put in the chat. We'll make sure that everybody can get to it. The syllabus has links to everything. So if you can access the syllabus, maybe it doesn't have the Slack channel itself, but it should be a good resource for you to get to the videos for training and to get to the pre and post assessment surveys and things like that. So I'm just trying to see, are people's questions being answered by Gareth? It looks like he's posted the syllabus and the TA in the Slack channel already. And Becca is going to pin them at the top so they're an easy resource. And there was a question about getting access to Openstar Lab. The answer is yes, we will be making that access available to you now if it isn't already made available to you. So I think these questions are being addressed and I don't need to do it. Okay. I think some of these questions are going to be addressed when Frans gives us a quick overview of Openstar Lab. So why don't you, Frans, give us a quick overview and let people know how they can get access to it.
Yes, I will. I have a very short overview today, and I'll have information on a training we'll do next week. Let's see, I cannot share, it says. Now I can share. Excellent. Okay. So just two quick slides on the Openstar Lab. Once the slides come up, you should see my slide deck. Just have a couple of slides here. So for all of the computations that you need to do for this course, all of the data processing and all of the notebooks that we will be looking at, all of those will be made available to you through a cloud-based environment that's called the Openstar Lab. The URL to the Openstar Lab, the one that you need to get access to, is listed on this slide. It is https:// and then unavgo.alaska.asf.alaska.edu. So this is the URL to use on the Slack channel. As we had discussed earlier, we can add that link to the Slack channel in that pin on the very top of the general channel, so that everybody always knows where to go. So the Openstar Lab is accessible to you through any web browser. So in order to go through the notebooks and participate in all the computational labs of this course, all you need is an internet-enabled device. So you can do it from your laptop, you can do it from your PC, you can do it from your iPad if you want. It's irrelevant what your operating system is. So for the sake of this course, there is no requirement for you to have a Linux machine or a specific, Ubuntu type setup. You can do it from a Windows machine as well as you can do from a Linux machine. Maybe quickly to what's on the right-hand side. Once you go to this URL, you should see a welcome screen that looks like the screenshot you see here. Once you're there, click on sign in. And on the next page that comes up, there's a button that you can see that says sign up. And if you click on sign up, you can sign up for the service. It will ask you for an email address. Please use the email address that you used when you registered for the course. So the same email address that you used for registering for the UNAVGO course please use that email address when registering for this Openstar Lab service. If you have issues with getting access to the environment, you'll see on the interface there's an email address that you can email. Alternatively, you can also post a question on Slack, and we'll look for those also. Okay, so this is how to get into the service. So as I said, it's enabled. It works with any internet-enabled device and through a web browser. The environment sits in the Amazon Web Services cloud. The reason why we picked AWS is because the SAR datasets that we'll be utilizing, they also are available in the Amazon Web Services cloud. NASA's SAR archives that are managed by the Alaska Satellite Facility, they are all located nowadays. The Sentinel-1 archive is located in the Amazon Web Services cloud. So this means that for the datasets that we'll be working with, you won't have to download any datasets to your local machine. You won't have to do any data processing on the your local machine for the sake of this course. The Openstar Lab is broadly installed with most Python-based notebooks that Python-based tools that you may need. It has all the notebooks again that we'll need for this course. I'm going to briefly go into the interface here in a second. Just one more note. We will do an optional pre-course training on how to use the Openstar Lab next week, next Monday. You will see an email to that extent with a Zoom link later today. And so we'll do it on Monday, August 16th, and it will happen at 11 a.m. Pacific Daylight Time. If you can make it, great. I think it's good to participate in this training and ask your questions that you may have, but we'll also record the training, and we should be able to replace the current recording that's in the syllabus with the new recording once it's available, to have the link in the syllabus code to that new recording. So if you have questions later on, you can rewatch that recording, and maybe your question is answered in that recording. So more on the Openstar Lab, I will talk about on Monday. Just briefly, once you were able to log in, let me make this a little bit larger here. You should see an interface that looks like this. This is your landing page when you come in. What you see on the main interface here is similar to on Windows, what your Windows Explorer would look like, or on a Mac, your Mac Finder interface. So it shows you the content of the Openstar Lab, the different folders and tools that are made available on the Openstar Lab. The main folder that you will need for this particular course is the folder called GeoSync. So if you then go into that GeoSync folder, in GeoSync, there's another folder that's called UNAVCO 2021, and that contains all of the notebooks and all of the tools and all of the content for this year's UNAVCO training. You see all the modules that are in here listed, and say if you go, I don't know, let's do imaging theory. If you go to one of these folders, you see there are subfolders called figures. There's a README file. But then there's also a notebook. And if you have never worked with Jupyter Notebooks, the way you identify notebooks on this environment is, it's two ways. First of all, there's a little stylized, book icon in front of these individual notebooks. So you may see, it's not that easy to recognize that that's a book, but that's supposed to be a book. And you can also identify the notebooks by the extension, which is IPyNB, which stands for IPython Notebook. And so that extension also identifies what these notebooks are. I may point out, you see that there's a little pop-up message up here. It says, like in this case, welcome to UNAVCO, glad you're here. You can close those. As we go through the course, if there's an update to something, we have the ability to message those out to you through these pop-up messages. So watch if the pop-up messages change, watch for those messages. It may tell you like, hey, don't forget to do your homework, or it may tell you, please restart your instance because we updated something, something along these lines. If you are eager to get started and you want to look at some of these notebooks already, please go ahead and do so. You can just do this by clicking on one of these notebook files. Once the notebook opens, which depending on the size may take a few seconds. So right now the notebook is opening. This is what these Jupyter notebooks look like. You'll see that they have both text content and sort of visual graphical content and explanations in them. You also see that you have other cells that are containing executable code. So in this case, this is written predominantly in Python. So mostly what we're using here is a Python kernel. You see that these notebooks are essentially built as a sequential series of individual cells. If I click on one of those, you see there's a frame around it. This is one of those cells in the notebook. There's another cell below it. And these cells are meant to be consumed or executed in the order in which they are given. So a notebook is a sequential series of text cells, so-called markdown cells. So this here, the cells that contain text, graphics, equations, etc., those are called markdown cells. You can also see this in the interface. When you see here, there's a drop-down menu that indicates this particular cell as markdown. And then the other types of cells are so-called code cells. You can see one of those code cells here. And again, if you look at the drop-down menu, it identifies this cell as a code cell. We are currently going through all of these notebooks and testing them one more time. One thing I want you to pay attention to, and I will explain it again on Monday, is each of these notebooks is running in a specific kernel. And what kernel it is running in is identified on the top right corner of the notebook. So here right now, this notebook specifies that it's running in a generic Python 3 kernel. For this particular course, and we'll try to update all of the notebooks as we go along over the next week, for this particular course, we built a specific environment that makes sure that all the dependencies related to all the notebooks are resolved and everything runs smoothly. You can imagine that we are using a large set of different Python resources here. We use a large set of different processing software packages like ICE, MinPy, and all of these other tools. And we developed a specific kernel for this course that makes sure that all of these different tools play well with each other, and we are not running into any conflicts within the environment. So make sure before you run a notebook that you pick this very specialized kernel for the notebook. In most cases, the right kernel is going to be pre-selected right away, but whenever you run a notebook, just check to make sure. And what this kernel should say in the top right corner is UNAFCO. So this particular notebook is not yet updated. So you can change the kernel by clicking on kernel. And then here on the bottom, there's a submenu that's called change kernel. You can switch the kernel to UNAFCO. And when you do that, you see that it's updating the kernel up here. Now the kernel is ready and it switched it to UNAFCO. So all the notebooks should be run in the UNAFCO kernel. And as I said, we are going through these notebooks now, and it will update the kernel to point to UNAFCO. If we forgot a notebook, to do that in a notebook, just make sure, check that it's set to the UNAFCO notebook so that everything runs smoothly. And then once you have set it to UNAFCO, you can go through the notebook and exercise all the code cells in sequence. Oh, maybe one word, and I'm going to also repeat this on Monday. To run one of these code cells, the way you do it is you click into the code cell so that it's activated, and then you can either click up here on this run button. So I just ran this particular code cell. You'll see that there's now a number next to the code cell that says 1, because I just ran this cell. It was the first cell that I ran in this notebook. If you don't like clicking on buttons, there are also shortcuts that are available for many of the actions that you would do, like running a code cell, etc. If you want to find out which sort of keyboard shortcuts are available in this sort of icon menu on the Openstar Lab, there's one that looks like a little keyboard. I'm not sure if you see this here where my mouse is. If you click on this little keyboard icon, it gives you all the the sort of shortcuts that are available. And there's one for running a notebook. Let's see if I find this. So there's like an Alt Enter, for instance, or Shift Enter that, Shift Enter runs a cell and then selects the next cell. So you could go through the notebook, doing Shift Enter to move from one code cell to the next and execute all the code. So if you're a fan of shortcuts, which I am, this is where you found out which shortcuts are available. Maybe a last word again, if you're new to notebook environments on the Openstar Lab, and again I will say that Monday one more time, in the main landing page where you come in, there is a subfolder that's called, that's called Notebooks. And in that Notebooks, oops, I have to sort of find out where the environments, sorry, tools. I don't see our help guide. I'll make sure that this shows up. We have help also available on the Openstar Lab. I have to find out where they were hiding this, and I will let you know on Monday. But there's some, oh, here, they moved it up here. So up in the top of the environment, there's a link that says user docs. If you click on those user docs, it gets you to a separate page where you see, get an intro to Jupyter Notebooks, there's information on how to run a notebook and so on. So there are all these different topics that are already being addressed, including like troubleshooting and FAQs. I think that's all I have for today. Again, a reminder, we will have a separate training on Monday, August 16th at 11 a.m. Pacific time, and you'll see an email and a calendar invite related to that here shortly.
That's great, Frans. So I'm sure that this is not so familiar to many people. I would encourage people, well, before I encourage people, I'm going to ask you, Frans, will your staff be available over the weekend to solve login problems if people have trouble signing up?
Yeah, so we have Alex Landowski, who is one of the guys that will be helping you out throughout the week, throughout the weekend. He may not, on the weekend, he may not respond to you like immediately, but he's, everybody's going to check both the Slack channel and the email address that's listed on the Openstar Lab regularly for questions that are coming in. So
I would therefore encourage everyone to try to sign up for their account as soon as possible, even though you may not be using it until later in the week. Since there are 150 people, some fraction of you will have trouble. I had trouble for reasons I'm still not sure about. So I needed to have an interaction with Alex. So I would encourage you to do it as soon as you can, just so that you're all set up by the time we need to hit the ground running.
And there are some questions, and Gareth has chimed in about people that would like to run things locally. I would encourage you for this course to try to stick to the Openstar Lab as much as you can. The reasons are because a local setup may run into different kinds of issues. You may have dependency issues that you need to resolve. We probably won't have the manpower to resolve 150 people's install issues this week. However, we will provide, I think we talked about this earlier when Paul Rosen went through the syllabus, we will provide you with a Docker container that will give you a setup that's identical. It will contain all of the software packages such as MinPy, ICE, and all of the SAR tools that you will need to do this on your local machine. It will also include all of the notebooks that you will experience this week. and will give you a very similar look and feel. So it's no issue to sort of try to get started on this early, but just know that we may not have the resources this week to respond to questions that have to do like installing things on your local machine. We'll try to get it to as many as possible, but it would be good for the sake of the size of this class if we stick to the Openstar Lab this week, or through this course. It's not to say that there won't be issues on the Openstar Lab, but the advantage is if there's an issue, everybody will have the same problem, and we only have to debug it once. That's sort of the benefit of having this centralized setup. But yes, we'll provide you the information that you're looking for in form of Docker containers and some instructions.
Great. Somebody, Kule, asked about the sharing the registration information for Openstar Lab. You mean the link? I think you just need to type in unavco.asf.alaska.edu, and then you'll come up to a sign in, and then a sign up set of prompts.
Yes, so we'll post something on Slack and with some instructions, and we can also put that in the email that we send out later. So Rebecca, I'm going to send you a template email to send out to the class. And then Esther, the Openstar Lab environment is auto scaling, so it will, when you log in, you'll see that the machine is spinning up. So for every user, we'll stamp out a separate cloud machine, and it sort of scales up with demand. So there's no formal limit in the number of instances that can run simultaneously. So each one of you will get a separate one.
So we're coming up on the hour, and I know it's late for a lot of people, so I'd like to not go over. We're going to largely repeat this on Monday at 10 a.m. Pacific time. So, and then that will be followed by the Openstar Lab training. So if you still have questions about this, about anything that we've talked about today, feel free to send them on Slack or attend again at 10 o'clock on next week on Monday. And for OSL in particular, attend the longer training, which will get you more familiar with the actual pointing and clicking. So with that, unless there's something really burning, somebody says he's confused about this. Are the pre-course materials supposed to be in a folder on Openstar Lab? So yes, there are indeed folders on Openstar Lab that have, I think, the numbering system of 0 point something. And those would be the pre-course materials that you could access. And there's also video links in the syllabus that will point you to those pre-course material video links where they exist. Okay, so Tuba says 10 or 11 a.m. on Monday because it was written at 11. What was written 11? So there's two things on Monday. One is a recap of this intro, similar to what we're doing today, followed by the Openstar Lab detailed training at 11. So I hope that answers the question. All right, cool. Looks like people are starting to find things, a couple of exclamation points. So maybe that's a great note to end on for today. I hope everybody has a great weekend. Look forward to seeing you Monday at 10 or 11 or both Pacific time on Monday to kick off the pre-course activities. All right.
And
thanks,
yes,
everyone.
Daniel, I think it's recommended to attend Monday at 11 if you can.
Yeah, absolutely. You should do
And
it.
there was somebody posted a link to the Openstar Lab earlier. That was the wrong link. Please use unavco.asf.alaska.edu. That's the deployment that we'll use for this course.
Right. Excellent. Thanks, everyone. Have a great weekend.